Hello, Algebra 2 students. I know this is not ideal and not how I wanted to start the semester. I especially apologize to my new students who I really only got to know for one day. Maybe I haven't even met you yet. So we will get through this. Again, I'm so sorry that this is how we have to start. I know that this is not the easiest way to learn, but I'm going to encourage you to hang in there and do your best. I've definitely slowing down the pace of what I would have taught had I been with you. So we're fine. We'll just slow it down and we'll do our best these next couple days. And my goal is I will see you on Monday. Okay, so we're going to take notes. If there happens to be a sub and you're in the room, I've printed them so you can do them just by following along each of the slides. If for whatever reason that handout didn't get passed out to you, you can take them on your own paper. You may just need to pause the video to have more time to write. And then there will be an assignment to follow. So we'll talk about that when we get there, but let's start with our notes. So I've labeled, this is slide 1 if you have the printed version. If not, you might want to, hand write the given functions. You don't have to, but those are the two functions we're looking at. Now, I had printed these thinking I would be there, so I was going to give a little twist, but we're going to just mark out the what's different, and we're just going to practice a couple like we've been doing. So what have we been doing so far? We've been adding, subtracting, or multiplying functions. So let's add the h plus g function and use -4 as our input. Another apology is I'm writing here with a stylus, so I know my handwriting will not be the best. So bear with me. All right, so I'm, for time, not going to work this all out super long, so pause and try. All right, when I plugged -4 into the h function, I got 28. Into the g function, I got -9, and then I realized the operation was asking me to add, so we should have gotten a final output of 19. Let's go to slide 2, and let's take those functions and practice subtracting. So we'll do h minus g of x. So again, pause and try. So here with x as our input, I'm just copying the rule for the h function. I'm going to subtract, but I'm going to subtract the entire g function. So that's where we stress the importance of putting parentheses so that we don't lose that negative sign. We'll need to distribute that negative. And then when we combine like terms, that'll simplify our final answer, but it'll just look like this expression or this polynomial for our new rule. All right, so that is where we've been. Where we're going today then, instead of adding, subtracting, multiplying, or dividing functions, there's a new operation where we can combine functions using something called composition. If you have the notes that I printed, it gives you this definition that in a composition of functions, the results of one function are used to evaluate the second function. What you'll need to write is this notation that's used. So this notation reads f of this open circle. We just read that f of g of x. Some people say it looks like the word fog, but that's really just an open circle, not a dot, so it's not multiplication. This is a new operation. It's called composing or composition of functions. I think about it as if you're reading from right to left, so kind of like reading backwards. So I look at what the input is, I plug it into G, and then whatever that answer is, I plug into F. Another way of writing it is like this, which is kind of helpful because when we think of parentheses, we always work from the inside out. So in this notation, I see I'm going to evaluate g of x and then use that answer to then figure out that answer plugged into the f function. Or down here's a nice little picture that kind of shows these balls are the inputs. They're going into the g function. Whatever the output is, that then goes into the f function, and then down here's my final f of g output. So it all sounds crazy, but let's try a couple. So we're on slide 4. Here are the two f functions and g functions given, and we're going to try to evaluate. Now I didn't write these, so you'll need to write the problem, which is asking us to evaluate f of g of 2. The first thing I like to do is rewrite it. So using that kind of parentheses within parentheses notation, again, sorry about the handwriting, I rewrite this as f of g of x, sorry, but not x. We're plugging in a 2, right? And then I'm going to work from the inside out. So I'm going to plug in 2 just into the g function. So that would give me, the g rule says to take 2 times the number minus 1. So that gives me 4 minus 1, that gives me 3. That's my output from plugging 2 into g, but now I have to use that and plug it into the f function. So the f function is to take 3 times the number, so 3 times 3 squared minus 3 plus 4. And then, of course, if we're evaluating carefully order of operations, I would take 3 squared is 9 times 3, so 27 minus 3 plus 4. And that gives me a final output of 28. So I'm still just getting one output, and I'm doing that by working from the inside out. So let's try another with 2 as the input again, but now instead of f of g of 2, we're going to do g of f of 2. So the problems look a little bit similar, but the order's different, which should make our answer different, because now, that handwriting's really bad, sorry. I'm still starting by plugging 2 in, but this time I'm plugging it into the f function first. So plug 2 into the f function, and I would get 3, what is up with my pen? 3 times 2 squared minus 2 plus 4. Order of operations again, so that's 3 times 4, so that's 12 minus 2 plus 4. And so that would give me 14. Don't forget we're not done. 14 is what I get from plugging 2 into the f function. Now I still plug that answer, 14. That becomes my input, and I'll plug that into the g function. So I'll take 2 times 14 minus 1 to get 27. So 2 different answers because the order was different if I plug f of g of 2 versus g of f of 2. And this is called composing functions, where we use our answer from the first function, plug it in to get our final output. On slide 5, we have an f function and an h function. Let's try h of f of negative 2. So again, I like to rewrite this to think about. I'm rewriting it or kind of thinking about working from the right side. So starting with my input, negative 2, I'm going to input that into f first. So where's my f function? That's pretty simple, negative 2 plus 7, so that gave me 5. But now I still take that answer and plug it into the h function, right? So the answer I get from my first output becomes the input now to plug into the h function. So the rule here is the number squared, so 5 squared, 2 times 5 plus 5. So my final answer, 25 plus 10 plus 5, would give us a final output of 40. I know it's so hard for me to try to get any sort of feedback without being there, but hopefully we're catching on. If you want to take a second and just see if you could start this one. So maybe pause and try. Okay, with our input of negative 3, we're going to start by plugging that into the h function. So hopefully you watched your signs. Negative 3 squared still becomes positive 9. 2 times negative 3 is negative 6, and then plus 5. So that function gave us an output of 8. And then I take that answer and plug it into the f function. Right? So now I'm going to take f of 8. And that would become 8 plus 7. So we got an answer of 15. All right, this will be our last slide. I'm going to skip slide 7 and 8. So the ones with the graphs, those will just save for when I get back. So if you want to try f of g of 2, notice there's 3 different functions. Again, the f, g, h just gives us which function to look at first. So if I rewrite this, I'm using 2 as the input, and I'm going to input that into the g function. So I'll take 2 plus 7 to get 9. Now that answer I'll put into the f function. So I'll take 3 times 9 to get a final answer of 27. All right. Last example. So definitely, if you haven't tried one on your own yet, now is a great time to pause and try instead of just going with my answer. See how you can do. Okay, so with all of these composition of functions, with that open circle, we're working from our input and then we're going backwards almost. Or if you rewrite it with the parenthesis within parentheses, we're working from the inside out. So plug -1 into the h function. Again, with negatives, you want to be careful. If you're using a calculator, we need to put parentheses. Or just in our head, that negative squared becomes +1, -2 plus 5. So that would give us an output of 4. Now I plug 4 into the g function. So g of 4 is 4 plus 7. So we should have gotten a final output of 11. All right, again, my apologies. I know it would be easier if we were in person. Hopefully with a video, though, one benefit is you can always go back and rewatch it, pause along the way if you need, if I went too fast in certain sections. We're now going to practice on Delta Math. So there's a Delta Math assignment waiting for you called Composition of Functions. And if you're new to my class, here's a code that you will need to add me as your teacher. I'll also post that on Google Classroom, but you'll need to add me as your teacher for you to see this. I have the paid version, special, of Delta Math, so there should be videos linked there too. So if you're getting stuck, you can watch their videos. That could just be a different perspective, a different way of presenting this material. Okay, thank you again so much for your hard work. Not the easiest way to start a semester, but I trust that you are still working really hard in my absence. And like I said, hopefully just a couple more days of this, and I will see you guys so soon.